This week is all about Hank Preston. No, scratch that. This week is all about Yang, delivered by Hank Preston. Hank Preston is a principal engineer that works for DevNet. The guy is amazingly smart. The guy knows everything, all Yang, all day. Please join us this week as we discuss Yang. And that's 6.
Do you understand?
I always feel like I'm blush a little bit as folks start introducing me in the pieces. Hank Preston, I'm a principal engineer in Cisco. Specifically, I work in the Learning and Certifications organization, and doing a lot of different things inside of our group. Previous to the Learning and Certifications group, I worked in DevNet. And all across those pieces, network automation has been an element of my passion. And what brought me to DevNet actually was the idea of network engineers transition into this world of programmability and automation. And so when Derek asked me to join today, it was an obvious choice. I was happy to come in, and we were talking about some of the things we might want to talk about and kind of dive deeper into. And we kind of settled in on NetConf, RESTCONF, Yang, model-driven programmability. It's a topic, it's actually one of the first topics I was assigned to build content for when I joined DevNet several years ago, because it was one of those cases, I think we've probably all been there. I pointed out we had a gap, that the material we had to help engineers understand what NetConf, Yang, and RESTConf were was kind of lacking and was confusing. And so I was told, well, go fix it. And that was my journey and introduction into model-driven programmability, was trying to figure out how to first understand it myself, and then come up with a way to try to help explain it to other engineers so that they could understand it. I've got a series of, as I was putting together material for today's session, I gathered up a bunch of reference resources and links and things, and so I will figure out how to send them. I'll send them into the chat, or I'll get them over to Derek so he can send them out to everybody that's invited here. But it's a list of things, some of the stuff that I've created over the years, some of the stuff that I've run across in different places. And so you'll have access to all of those. Rather than do my traditional kind of introduction presentation, which is kind of PowerPoint driven and going through, I figured we'd do it a little bit different this time and be more interactive and demo based. And that's my focus for today as we dive in. I am going to start with just a couple of slides so that we can define what model-driven programmability is, because I think that getting everybody on the same page about what exactly it is that we're talking about is a good place to start. Derek, can you pass the Hank Preston 3 not connected to my DX70 the ball, please? There you go. Now I got it. Cool. There we go. Excellent. All right. So the slides that I'm going to be showing here actually comes out of a Cisco Live presentation that I've done for a few years. Sometimes I double team it with a coworker of mine, Brian Byrne. And it's a 2-hour breakout in Cisco Live focused on model-driven programmability. I have a link for that session where the slides are downloadable, and you can watch the full video of that if anybody wants to spend more time on those. But that's where the couple of slides we're going to look at is coming out of. And so you'll get a chance to grab those links. All right, so we've got model-driven programmability is our focus here. And there are several different protocols and technologies that go into this idea. In general, we're going to be focused most of today's conversation kind of looking at this from a device basis. So running model-driven programmability to talk to a network device that's out there. And so in our drawing here, the large green rectangle represents my network device, and you can see it has a series of network features on there, maybe interfaces, it's got routing protocols, access control lists. And so those are typical. We've worked with network functions and network features for years. All the new stuff is what sits on top of it, because our goal with model-driven programmability is to interact with these devices in a programmatic way, something other than just the native CLI. And so at the top, we can see kind of the transport protocols, the API interfaces that we can talk to this device with. And we've got NetConf, RESTConf, and gRPC is a third one. Those are different ways that you can talk to a device. We generally talk to CLI-based devices, either with SSH or Telnet, mostly SSH these days for security reasons. You can think of netconf and RESTCONF and gRPC as different ways to talk to that device. And then Yang comes in underneath it. Yang provides an ability to create data models. And we're going to talk a bit about what that means as we go through today's session. But the data models are standard ways to describe those features on the network device. And the data models kind of roughly get grouped into two buckets. Data models related to configuration of the features, and then data models related to the operational aspects of a feature. So the easy difference of this from an interface perspective is that the IP address that you want to configure on an interface would be a configuration element. The number of packets or errors or jumbo packets or CRCs, those are operational aspects. You don't configure that, you just read that. It's like state data. And so Yang gives us the ability to connect or to read or read and manipulate both of those pieces of data. And then who defines the models kind of fall into two rough buckets as well. These can either come from standard organizations like the IETF or OpenConfig, or they can come from the vendors themselves. Cisco, Juniper, Arista, Huawei, all of the vendors out there are making vendor-specific models, as well as supporting a variety of different standard-based models that are out there. And so when we talk about model-driven programmability, it's kind of an all-encompassing term for the transport protocols, right? Our interfaces at the top, as well as these standard definitions of how we're going to describe what the features that we're trying to interact with. Now, gRPC or GMI, and there's a lot of these other things that kind of fit into that portion of model-driven programmability. They fit into this overall umbrella, but they aren't IETF standards. They're kind of emerging as standards, but more based on kind of open source community work that's in there. I'm going to focus very much kind of in the netconf, RESTCONF, Yang, the IETF standard portions of model-driven programmability for today's session as we go through. So we're going to start, now I'm going to jump over to kind of the demonstration portion of this, and we're going to begin our story by looking at this RESTCONF mechanism to talk to devices to access the data off of our interfaces that are there. And I'm going to start with RESTCONF because I think as network engineers get involved and look into network automation, an easy way, one of the easiest elements to get into programmability is often REST API based. And that's really what RESTCONF is. RESTCONF is an IETF standard REST API for the network. And so let's see what it looks like to talk to our devices with a REST API. Now for this portion of the demonstration, I'm going to be using Postman. If you haven't run across Postman yet, I encourage everybody to take a look at it. It is a client for kind of manipulating and working with REST APIs. There is a free version of it. There's a paid subscription you can do. For most network automation engineers, the free version is more than sufficient, and that's all I'm using here. It can also do far more than just make API requests, but that's the entry point for us, is we're just going to use it to make some REST API requests. I'm not going to go super deep into the details of everything that goes into REST APIs on today's call. I'll hit the highlights as we go through, but if anybody has questions and doesn't understand a term I'm using, just come off mute, let me know, and we'll kind of dive into those as we go through. I've got tons of material that we'll go through. We'll see how much of it we get through before our end time today. What time do we end, Derek?
Oh, 2:30. We're trying to wrap it up before 2:30.
Okay, perfect. That gives me a clock to watch. Okay. So the first thing with our REST API requests is we have different methods that we can make. We're going to start out with the GET request. GET requests are how you retrieve information from your network device. Now, the network device that we're going to be working off of today is one of the DevNet sandboxes, particularly one of our always-on iOS XE-based sandboxes, and you can see the details here that are in the corner. Postman lets me use variables to kind of insert into different elements, and so you're going to see me go through there. But the host address is here. Here's the port we're going to run on to talk to RESTCONF, and then the credentials are also listed there. And so we're going to start out with https:// and then we need the host. Remember that double curly braces is the reference to the variable that we were just looking at. And then I'm going to say the port. device happens to run RESTCONF on the standard HTTPS port, which is 443. So I could have left that off, but as I work inside of Postman, I often am explicit because then I can jump from one device to another, and another device may use a non-standard port. Now, RESTCONF starts out with, at the URL path format, just the RESTCONF and then data. And that's kind of how we jump into RESTCONF. That's the entry point for all of our REST APIs with RESTCONF into these devices. Not every device that uses RESTCONF will go for at the data pieces here. There are ways to ask the device where the things are, but in general, you're probably going to find most of them are like RESTCONF data as we go in. And then after that, this is where the Yang models start to come through, and we specify what we're interested in by going through the Yang models that are in place. And we're going to kind of peel the layers back on those as we go through. But I happen to know some of these off the top of my head. So IETF interfaces is a IETF standard Yang model that is supported by a number of devices. I like this one to as part of my education and learning about RESTCONF and Yang because it's a simple network interface model. Doesn't have a lot of the complexities that might pop up as you get into some of the other model choices like the open config models or then vendor native models. But we're going to start here. And then interfaces. Now this URL, so I'm asking the IETF interfaces Yang model and then the interfaces portion of that model. We'll see what that is in a second. Now I'm going to go ahead and try to send this API call off and see what we get. So the first thing we notice here is I get my 401 unauthorized. This is the status code that came back. If you started to explore REST APIs, this should be somewhat familiar. 400 series error codes indicate something is wrong with my request. The 401 specifically is called unauthorized, but it's really unauthenticated. We didn't provide the username and password necessary to talk to this device. Just because we're using a programmatic API doesn't mean that we bypass any of the AAA or the RBAC pieces. So the next thing I'm going to add is I'm going to go to this authorization tab and switch to basic. REST APIs have a number of different ways that you can authenticate. Basic is the most one of the most simple ones that are in there. And you just have to provide the username and password here. Postman takes care of all of the things that have to be done to that username and password to include it with the actual HTTP request. We'll see what those look like in a second. So once again, I'm going to use my variables in Postman so that I can put them in there. By looking here, my password is just the password. So these are pulling through. And if we just look at the little eyeball, we can see the username's developer, the password Cisco12345. So that's what's going to get injected in. So I've added those through, and now when I send my request off, look at that. I got some data back. Now, if you've worked with network automation and you kind of use any of the number of CLI-based mechanisms for automation using NetMiko with Python or some of the others, you're probably used to getting back the same type of text output that you get when you work at a CLI, and then you have to use different tools to parse them. One of the main values of model-driven programmability is that the data already comes back structured and described. So in my list here, it comes back in an XML format, and I can see that there's my interfaces, and then I've got a list of interfaces. Here's the first interface. It's Gigabit Ethernet 1. It has a name. It has a description. It has type, enabled status. If I scroll down a little bit, we'll see we have Gigabit Ethernet 2. Scroll down a little more, we can see Gigabit Ethernet 2.40. Looks like someone went ahead and is configuring some sub-interfaces. There's Gigabit Ethernet 3, and the list would just go on and on and on. Now, RESTCONF has, as a REST API, you have other options other than XML-based data. But because this is RESTCONF and we didn't explicitly specify what type of data we were interested with, the device gets to pick its default choice. And we can know what type of data came back by looking at the headers off of our request. And we can see here it says content type, application, yang-data plus XML. So this is the header that came back from the server telling me what the type of data is. But I can use this to manipulate what type of data I get back by setting an accept header. The accept header lets me tell the server what type of data I want. In this case, I want to flip from XML to JSON. And so I'll just change it to plus JSON at the end down here. And then we'll go ahead and we'll resend. And look at my body. I have the same data. Now it's simply formatted in JSON. To some extent, it's kind of the developer or the automation engineer's choice. Which format do you prefer, XML or JSON? Depending on what I'm doing, I jump back and forth between the two. But we'll stick with JSON here because it is slightly easier to read because there's less tags than we see with the XML output. And so we can see all of the details that are here. All right, any questions so far?
Awesome.
All right. So let's continue down our path. Ooh, was there a question?
No, I was commenting. Good stuff. Thanks, Hank.
Okay, cool. So this is RESTCONF. RESTCONF is the definition of the structure of the API, and this is again a REST API. So RESTCONF is how we know that it's HTTPS. It's how we know that it's RESTCONF/data. It's how we know what GET does versus put and post and the other ones that are out there. The format, kind of the way that the data is laid out here, this is where Yang comes in. The device knows how to structure the response data because of the Yang model that's used under the hood. In this case, again, it's using the IETF interfaces Yang model is what we're going after. And any device, whether it's Cisco or Juniper or Arista or anybody who leverages and uses the IETF interfaces Yang model will send you data back that looks in this format. So fundamentally, I could take this same kind of description of a network interface configuration and send it to any device that supports this model, and that same layout works. Now, this is different from a kind of a traditional CLI-based approach, where you can't take just the CLI configuration from one device and necessarily send it to another device unless it happens to run the same software version. And even within Cisco, when you go from one platform, such as iOS, to maybe iOS XR and XOS, that CLI configuration could change a little bit. But if you have the same Yang model, if the devices support the same Yang model, you should be able to take that configuration and make it portable between devices. The other thing that's nice about having a known description, something like a Yang model that defines how this data is going to function, is that as a network automation developer, network automation engineer, you can look at those Yang models and then you can anticipate what data you're going to get back and what the format is in, because the models are like a specification. I don't know about everybody on the call, but I know a lot of the network engineers I talk to have backgrounds in other portions of IT, maybe database development or comp sci, things like that. I think about the data models like a table schema. One of my first gigs in IT was around databases. So I often go back to my old database days. And when I would create a table definition, I would say, okay, there's going to be a column called IP address, and it's going to be a string. And then there's going to be a column called date time or modified, and it is going to be a type of a time format. That's the same idea behind the Yang models. The Yang model says that we are going to have a list of interfaces. Each interface will be uniquely identified by a name. That is the key. Each interface will have a description that is a string. Each interface will have an enabled stack, Boolean flag, true, false. That's the value of the Yang models, describing exactly what it is that you're going to get back. I'm going to jump for temporarily, and let's go actually explore this Yang model itself a little bit. All right, I'm going to switch over here to VS Code, and we are going to look at, where is it? Here it is. IETF interfaces Yang. Now, one of the things about the word Yang when you're starting to learn about model-driven programmability is you may hear it in kind of slightly different contexts. The actual standard, what Yang is a data model creation language. That's what the RFC defines, is how you create a data model, how you describe a series of lists of interfaces and the types of attributes that it has. And so when I open up the IETF interfaces.yang file, this is what I'm looking at, is kind of the definition in kind of the Yang language format. This one comes from the IETF, and I'll show you in a moment where you can actually find these up online on GitHub. But if I were to scroll through this, actually, you know what I'm going to do is I'm going to start by jumping to the very last line in this model, and we can see that there are 726 lines in this file. A lot of this file is like clear text descriptions about what's going on. This one at the very end you can see is called a leaf out errors. And so this is describing an attribute that's part of this model that is output errors. And you can kind of read what's involved. There's reference information as it goes through. As a network engineer, a network automation engineer trying to use model-driven programmability to interface with your devices, looking at the raw Yang files is not necessarily conducive to being productive. It can become overwhelming with the amount of data that's in there, which is why I often recommend using different tools than just looking at the raw Yang models to explore those. And so now I've switched over to a terminal window, and I am at the same point that I was in VS Code. So right here, this is that IETF interface. Where'd it go? IETF interfaces Yang file. That's that text file we were just looking at. I'm going to use a Python library called pyang. You can get this with a simple pip install pyang. And I want to format that Yang model in a tree output, and you'll see what that means when I display it. And I want to look at the IETF interfaces Yang file. So when I run that, what the pyang program does is it reads through that Yang file and then can format it in a slightly more user-friendly or consumable fashion for me. So now I'm looking at, here's my IETF interfaces Yang file. We can see that it has two, these are called kind of containers as they go through. This one is about interfaces. This one is interfaces state. The key difference here, if you think back to that when I first started, there was configuration and operational data. Interfaces container, this is configuration. This is how we define the configuration of my interface. Interfaces state, this is all of the operational detail. And that, as you can see, we've got all the counters and information down here at the bottom. Now, the reason I know that this up here is configuration is because this RW at the front tells me that that's a read-write element inside of my data model. I can write an interface description. I can write an enabled status. Down here under interfaces state, it's RO. That means it's read-only. That's operational, sometimes called non-config data inside of Yang. And so here we can see I can read what the admin status of an interface is, but I can't write it. I can't configure the admin state of an interface. That's an operational aspect. Similarly, I can't write how many octets have come into the interface as they go through. That's a read-only attribute. So this Yang model is what defined that RESTCONF request that we made. So let's kind of look at the two of these together. If I switch back to Postman, remember what I said, this portion of the URL is kind of the standard starting entry point for RESTCONF interaction in my device. It's all RESTCONF/data. And then after that is where the Yang model starts to come in. We can see that we've got IETF interfaces, then colon interfaces. This is the reference to the model that we're talking about, and then what inside that model are we after? And so IETF interfaces, colon interfaces. If I switch back to my pyang output, we can see here's the module name, IETF interfaces. That was before the colon. And then interfaces is this container that I was after. We can see that it's that top level as it goes in. Now I can change from interfaces. We've got another option here, interfaces state. Let's see what happens if I switch to that instead. So up here in the URL, I'm going to change from interfaces to, there we go, interfaces state, and I will send this request off. What output do I get now? We can see that in my output, instead of the configuration information, now we're getting back all of that, the operational details that are in place. We have the ability to see those in and out counters as they go through. We'll also notice here in the output, the top level kind of part of the JSON shows IETF interfaces colon interfaces state. To do a compare and contrast, I'm going to bounce back just to interfaces. Now we can see it's back to just interfaces. And instead of the operational details, we see the configuration information that's in there. So this shows us how the Yang model allows us to know how to manipulate and work with the device using RESTCONF as an interface as it goes through. All right, any questions? All right, so let's peel it back another layer. What I've gotten so far here is we're looking at the configuration details. I'm going to change back to the state details for this next demonstration. Okay, so what do I have down here in my list? If I collapse down, we can see that I have in my output lots of interfaces. I'm down to gigabit Ethernet 3, loopback 721, loopback 99, and so on. There are lots and lots and lots of interfaces. Now, suppose I was interested in just a single interface, right? Sometimes we're not interested in all of the interfaces. We're interested in just one interface. So if I jump back and we look at our Yang model, we can see that under interfaces, we'll have a list of interfaces, a list of interface. We'll have more than one of them, so the plural and the name gets confusing. But when we're talking about the list itself, the list is called interface. And then this thing in the square brackets indicates how we uniquely identify each individual interface, and it's done by its name value. And the name down here is a string. All right, so how can we use that? If I come back over to RESTCONF, I can say, okay, interface state, and then with a slash, I start to work my way through the Yang model. The next thing that was option was interface. Remember, we were interface is state, and then the name of the list is interface. Now I want a very specific interface, and so I can just say equals, and then I provide the key value that I'm interested in. Let's say I was interested in gigabit Ethernet 2. So inside of here, I'm interface equals gigabit Ethernet 2. That will let me hone in on just a very specific interface on my device. Send this off. And look at that. My response comes back. It's IETF interfaces interface. And then I've got name 2. And if I scroll down, you'll see that's the only data I get. I didn't get all of the interfaces. I just got the exact one I was after. And that, again, the way that the URL is structured is based on that Yang model. I go back to my output. Here's my IETF interfaces interface. And then the equals the name that I was after. Now we can continue down this path with RESTCONF, drilling in deeper and deeper into the exact part of what we were interested in. Suppose we are interested in just the admin status of our interface. Well, we can continue with that by saying, okay, once I've got my interface, I just do slash admin status. And I see that my data that gets returned is now honed down to just what I asked for. The IETF interface's admin status for this particular interface is up. And so now we can see how with our RESTCONF API, we have the ability to drill directly into the type of data that we're after. And this is a great way to get started with model-driven programmability, because we're just requesting detailed data from our network. We're going to I'm looking at the clock. I'm going to do the next thing we're going to go into is I'm going to show you how we can actually manipulate the configuration with RESTCONF as well. But I want to pause, see if anybody has any questions about retrieving data and kind of looking at that manipulation.
Yeah, so if you left out that qualifier interface equals gigabit Ethernet 2, but you put the slash admin status, that would show you just the admin status of all the interfaces?
Let's see what it does. So that's what you meant, right? Take away the key value?
Yeah.
So we can see that we get 404 not found because we didn't specify one. I am fairly certain there's a way to say all. I know there's a way that you can go through and say what you're after to do that so that you can get them all back. But with RESTCONF, I don't know those formatting as much off the top of my head as I do with netconf.
Okay.
I remember. So if I just do interface, we can see it shows them all there. Let me see if I can figure it out.
Okay, I don't want to rat hole since we don't have a lot of time. I was just curious.
Yeah, there is a way to do that so that you can get all of just the interface status or the admin. I'll have to. I probably won't get to it on the call, but I'll figure out what it is, and then we'll send it out and figure out how to let everybody know how to craft that so that we could limit it down to just that field for everything. I do not recall it off the top of my head though. Put it back where we were. There we go. Good question. There is a way. I just can't remember off the top of my head.
Okay, so I have a question. So I know most devices comes this day with the Yang model already installed. So, but do you need to do like to use Postman to get anything from there? Do you need to ensure that anything is activated on those devices, or if a device already have that model, you can just get it out?
So look, I think I understand the question. So the idea is like, how do you know that you can talk to a device with RESTCONF and what's available? Or do you have to do anything
Yes.
to make that work? Is that kind of the gist of it?
Yes.
Okay. So before you can use RESTCONF with your device, the feature has to be enabled. And so every device and vendor will have different ways of enabling features on the device. With iOS XE, it's fairly simple. RESTCONF is the configuration command to turn it on. Similarly, netconf-yang turns on netconf. Because netconf and RESTCONF require username and passwords to authenticate correctly, you do have to have at least a little bit of a AAA configuration configured. So you have to have like an admin user created that RESTCONF that you can use to authenticate. So if you're just using like enable based or line based authentication, you won't be able to get into RESTCONF. But so AAA, basic AAA, and then enable the feature on iOS XE. On Nexus, I think it's like feature RESTCONF turns it on, feature netconf turns it on there. I don't know on other vendor devices, but I would say just check the manuals or the instruction, the programmability guides for your device to figure out how to turn the features on. So that's the first part, is just getting on. The next question is, how do we know what models are supported, I guess, on the device as they go through? In general, many devices, when you download the operating system or the OS version for a platform, it is going to include the Yang models that would be supported on that device. There is some devices have the ability to add additional models to them afterwards. The one that I know specifically that's like that are Nexus 9000 switches. When you enable RESTCONF or netconf on a Nexus 9000 switch, the operating system NXOS comes with the native models. Out of the box, you've got those. But if you want to use like open config models, they have to be installed after the fact. Cisco additional models. iOS XE, what the operating system ships with, models that you have to. There is a way to ask models supported. I've got an example here. There's a kind of a standard model that support REST should have. It's part of the standard. And it's called the module state. So if I send this one off, what this will give me, there we go. So this gives me a response back of the models that are supported on this device. And iOS XE devices have a pretty supported well as native. But in the models that are supported, so if I do a search in here, you can see those IDF. So down here in that request that I made, this IDF model that is supported, we can see the revision information, so which version of it. So the IETF interfaces model has been updated over time. We can see exactly which version of that model is supported by the device. there are things inside of the standards that allow different vendors or different consumers to make slight changes or deviations from a model. So this one, we can see the Cisco iOS XE, there's some slight deviations that are filed. I don't know which ones they are specifically on this one as they go through, but we can see in this list all the models that are supported. So when you start to work with a new device with model-driven programmability, a common first step after enabling the features is to make this request of, well, show me all your modules. Show me what modules that you work with that I can leverage. And then from there, you can start to explore those models and see what's using a number of tools that are out there to check them out. That answer your question?
Yes, thank you.
Yep, excellent. All right. Any more? All right. So the last thing I want to show here is we've been just doing some GET requests. I wanted to show what it was like to actually make configuration changes to a network device using RESTCONF as well. So I'm going to, is someone trying to come in with a question? All right. Excuse me. So I've grabbed out of my collection over here an example that I had, which is going to configure an interface using this IETF interfaces module that's there. So I've got, instead of GET, now I'm going to do a put. The URL looks very similar to what we were just looking at. IETF interfaces, interface, gigabit Ethernet 2. And so we're going to be targeting gigabit Ethernet 2 on this device. And then in the put space here, we specify what configuration for this interface do we want to apply? What do we want to put onto this interface? And so first, let's look and see what the current configuration on gigabit Ethernet 2 is so that we can compare. Ooh, that's the state. We need the actual configuration. All right. So we can see right now it's gigabit Ethernet 2. It has a description of South customer and an IP address of 10.10.10.10. And so suppose we wanted to change some of that. All right, so we've got our description here of configured by RESTCONF, and then this body happens to have an IP address of 10.255.255.1. And so if I send this body, we can see that that's the body value. Now, the other thing we need to do is we have to make sure we let the device know what the format. Basically, are we sending data in XML or in JSON? In this case, it's JSON. So if I look in the headers, we can see that I've got the content type header set to the application yang data plus JSON. So the value is the same as we used with the accept header to tell the device we wanted JSON. Now we're telling the device that we're sending it JSON. Here's the body that we're going to send. I click the send button. And in my status, I don't get any data back, right? Nothing came back. The way that I know whether it worked or not is this status code, status 204, and then no content. If I hover over it in Postman, it popped up and then went away. There it goes. We can see that the server successfully processed my request, but did not return any content. That's what RESTCONF does when you ask it to make a change, is it just tells you, hey, did it work or not? A 204 says, yep, it worked fine. If I got back a 400 something, that might be an error for indication. If I want to see if this was actually successful, if I flip back to my GET request, send it again, we can see that my description is now configured by RESTCONF and the IP address is 10.255.255.1. So we've been able to update the configuration of this interface. Now, a common confusing piece that can come through for users that are getting used to RESTCONF if they've explored other REST APIs is that a common method instead of put to make changes to in a REST API might be post. RESTCONF supports both post and put, but they have slight or significant but slight differences in when you might use one or the other. Post creates a new object on a device. Put updates a currently configured object on a device. When you're talking about a physical interface, such as gigabit Ethernet 2, I can't create a new physical interface on a network switch or router. At least typically you can't do that. right? I can't just send an API call and have miraculously an additional gigabit Ethernet interface like get installed into the chassis that's there, assuming this was a physical piece of gear. This is why I have to put, because the actual interface, gigabit Ethernet 2, even if it's unconfigured, already exists on the device. But if I was trying to manipulate, let's say, a loopback interface, then I can post to a loopback interface, because loopback virtual logical interfaces, you can create those. There are other logical interfaces on many network devices, port channels, SVIs, all of those types of things that can actually be created, you can post to. But physical interfaces, you put the configuration onto them. And that's a common question that comes up a lot as I work with users that are trying to figure out why their configuration isn't quite working right. When you're dealing with physical interfaces, you can't create new ones. You just update the config. Similarly, if I wanted to delete a loopback interface, I could just send a delete request. But I can't delete a physical interface, right? I can't have it be removed from the chassis by sending a delete. So you would just put an empty set of configuration if you wanted to remove it on that side. So slight variations on put, post, and delete, depending on whether it's a physical interface or a logical interface as they go through.
What Hank just described to you guys will actually save one or two or three of you guys a whole weekend or a whole week of troubleshooting. I promise you that. So mentally store it.
It comes up a lot. Absolutely. Okay. So I often talk way more than I expect. So as I mentioned at the start, I've got lots of material planned. I'm not going to get anywhere near close to it. Derek, if you ever want to do a part 2 of this, I'm happy to set something else up and we can dive in. I'm not done yet. There's a couple of things else that I wanted to share, but I'm not going to get through everything that I hoped to today.
No worries. Well, first, let's take. Anybody have any questions or need clarity on anything?
I had a quick question, actually, maybe possibly two-part. But are people using, the REST API to monitor network devices too now?
I think your audio is a little bit low, but I think the question was, are you using REST APIs to monitor? I would say absolutely. I know in our team, we're using RESTCONF and other APIs like this as part of our monitoring strategy.
Oh, yeah, because I was gonna say I was in my old job I was using ccnp monitoring, and I was creating profiles for network devices and Datadog, and that's how we would monitor network devices then.
Yep, I would say so. One of the things I talk about in the Cisco Live presentation that I mentioned, I'll have a link for everybody for, is kind of the history where model-driven programmability came from.
Mm-hmm.
And it really is, from a standards body perspective, an evolution coming out of SNMP. And so all of the ideas that drove us to Yang, RESTCONF, and NetConf are built on top of the work that we had done, and then as a network engineers in the networking industry with SNMP, and trying to solve some of the challenges or usability things that had made SNMP not for every use case that was out there.
Yeah.
And so in general, if you've used SNMP for a use case and your device supports NetConf and RESTCONF and Yang, you should be able to start moving in that direction as they go through. That doesn't mean SNMP is going to go away tomorrow, but we are starting to see lots of monitoring tools starting to take advantage of some of the efficiencies of these new protocols.
Yeah, no, that makes sense. I was just thinking about it, with Python, it's pretty easy to parse the JSON and,
Oh yeah.
do stuff off that. So,
Hey, what about in the future? Maybe a model-driven telemetry webhook. No, you have any material like that you put together?
Your audio broke up a little bit there at the end, Derek. So
That me?
repeat it.
Webhooks and model-driven telemetry. Did you do a session like that prior, or do you have anything you can put together for that?
So I've been diving into model-driven telemetry a little bit myself, and it's definitely a topic worth another session to dive into.
Okay.
For those that aren't familiar with that term, model-driven programmability and model-driven telemetry are very much related tech or tools. They leverage the same types of protocols. Model-driven programmability is kind of about making configuration changes to your device and then kind of point-in-time operational inquiries. So I'm interested in what the stats on this interface are, and I'm going to use RESTCONF, and I'm going to make a request to the device. model-driven telemetry is focused on kind of the operational side, the counters, the state, the health information, the metrics from your device, but rather than kind of this polling mechanism like we would have with a RESTCONF request, the protocols that are built into model-driven telemetry are built around kind of pushed out notifications, on-change updates, efficiently packaging up what could be lots and lots of telemetry data, just metrics data from the network, and processing them and using modern tools like time series databases like InfluxDB, visualizing them in some of the newer tools like Grafana on that side. So definitely a related kind of logical next step to dig into after you kind of get your head wrapped around model-driven programmability.
But Max, to go back, this is there's a ton of geeked out arguments and articles on the internet, especially when it deals with S&P and how model driven telemetry is the future to I know Hank. I saw Hank produce something like that before, so maybe we go back through. But we later sessions. Stick with us. So sorry, Hank, I didn't mean to hijack you.
Oh, no, it's all related. Absolutely related. All right, we've got, let's say, about 10 minutes left. I'm trying to decide what to show next. And I think what I'm going to do is spend a little bit more time on the Yang model piece and other tools and options that you can use to look at those. And so what we looked at last was Yang. I will be honest, my normal mechanism for interacting and exploring Yang models is I use the Yang kind of CLI tool to crawl and craft and kind of look at what the Yang models look like and work with them. But many people have been trying for years now to come up with better tooling, graphical tooling, more user-friendly tooling to work with and manipulate the Yang models than just CLI tools or opening up text files. So I'm going to stop sharing here. And Derek, if you could switch switch the ball over to the other me in WebEx.
Wrong.
I will share over here. Excellent. I got it. So one of the things that was recently released from Cisco as a free product that you can use is called Yang Suite. And Yang Suite is kind of the Cisco effort to build really good tooling to help users understand and work with model-driven programmability models like Yang. Now, I'm not going to go through how to install it or set it up. The documentation is pretty good for those, but I do want to show kind of how you might use it in a similar fashion to what we've been talking about so far as they go through. So Yang Suite is here. The first thing you need to do after it's installed is you need to kind of tell Yang Suite what Yang models you want to explore and work with. There are a couple of ways to do that. You can set Yang Suite up to talk specifically to a device on your network, and then it will pull down the Yang models that device supports. Another advantage you get if you do that is that Yang Suite can operate kind of like Postman for the netconf protocol, which we didn't really dive into yet, and kind of craft and execute netconf requests and things against your device if you connect directly to it. But what I've been using it for is actually separate from the devices themselves, because you can create a repository of Yang files inside of I already created one called demo, and then I just did choose file, excuse me, and then uploaded the Yang a few Yang files to Yang Suite, and so you can see that I've got the IETF interfaces Yang file uploaded, as well as a couple of others. IETF IP is another Yang file, Yang module that does what's called augments the IETF interfaces. And so what augment means is we've got one Yang model and we want to add some additional features, aspects to a Yang model that's out there. We had seen before when we looked at the IETF interfaces, it had some basic interface detail, but you may not have noticed it. What it actually was missing was like IP address configuration for an interface. The IETF IP model actually augments it and adds IP configuration. So I added that one as well. And then INET types is type definitions of different types of interfaces, loopbacks, Ethernet interfaces, and so on, and different pieces. So I've just got a handful of Yang files here that I uploaded. And then after you upload your files, you have to create what's called a module set. And this is where you then group together a series of Yang modules into kind of a logical grouping. Yang Suite is built to be a very robust tool where you may be manipulating and working with Yang files from multiple devices, multiple versions of software as they went through, which is why Yang Suite is set up with this type of hierarchical structure. Is so that you could have maybe a Yang set for iOS XE version 17.2, and then another Yang set for iOS XE version 17.4, and you can jump between them as they go through. When you're just working with a couple of Yang files, it can seem a bit kind of overkill on that side, but that's why it's built that way. So once I've got my Yang set here, we can see I've added those same files over here. Now I can begin to explore them. So if I choose my demo here, and then I can say, well, what Yang model do I want to explore? And we're going to do that same one we've been using, IETF interfaces. And I'm going to say, load that module up. Now in this nice web interface, I can point and click and look at the Yang models the same models that we were looking at in Pyang, but now they're graphical. And so if I click on name as an example, it'll show me the details. It's a name, it's a string, it is the name of an interface. What I like about Yang Suite is it lets me over here on the side see kind of the visual representation in a simple fashion. But if I want to understand what is meant by name, it does easily kind of in that same layout show me what the description is. So I can read right out of the file what designers of this model intended for that to be. Now, the name of an interface is fairly easy and intuitive, but if I jump down to interfaces, state, and statistics, and I look at something like we'll say in errors, maybe I'm curious as a network automation developer, like what's meant by in errors? Like what is that information going to mean? And over here, I can see for packet-oriented interfaces, it's the number of inbound packets that contained errors preventing them from being delivered. And we can see there are lots of different counters that go through. And so Yang Suite, as a network automation developer, I'm writing a program, maybe for one of those operational use cases that Max was asking about. And I'm trying to figure out, what is this data? Like I got a bunch of data from the device, and I know that I'm interested to find some piece of logic or information out of it. I can use Yang Suite to kind of go through and say, well, what's the difference between in octets, in unicast packets, in broadcast packets? I can click on each of these and then read and explore what's meant by them on the side. It's a really nice tool for interfacing and interacting with Yang models as they go through. And then if you wanted to, you can actually use Yang Suite to kind of explore how you might interact with the device, again, with netconf or gRPC. Now, if we had a bit more time, I was going to go into netconf, compare and contrast that with RESTCONF. We're about out of time, and I don't want to try to rush it in 10 minutes, so we'll save that for maybe a part 2 down the road. But this is another good tool for kind of interacting with Yang, understanding what's out there as it goes through. All right, I think that's a decent stopping point for today, Derek. We can tackle questions that folks have, and I will be sure to send you the list of suggested resources for anybody that wants to dive deeper into this topic.
Oh, no worries. Thanks, Hank. Look, I just want to make sure everybody understands the amount of gold that Hank just laid out to you. To be honest with you, I've I've never used Yang Suite, and as I'm looking at this, I probably should be using Yang Suite, right? I do a lot of guessing and documentation and what have you, to get my URIs or URLs together. But this is awesome information. So if anyone still left that have any questions or maybe a question on when they would use it, feel free to ask. You can use the WebEx Teams room or you can ask on here. But I'm gonna open up the questions. Anybody have any questions?
Yeah, I'll go first. So my question was going like when to use it. There are so many tools in the automation. I always confused where to start. Go with Python, Ansible, then this one. So when do we really need to use this one?
That's a tough one. Because it's one of those typical tech question or answers that it depends a little bit. But I can give you some things to consider on when to pick tools to go through. Um, I often am asked, or I think back to questions that I used to get, and we still hear occasionally, like, which routing protocol should I use? Which one's the best? EIGRP, OSPF, ISIS? And the answer I would always give an engineer at that point is I would say the one that you should use is the one that you know how to use. The best routing protocol is the one that you can turn on and use effectively. When we talk automation, to some extent, that is a similar answer that goes through. I am firmly in the belief that being exposed and understanding what potential tools are out there, what you could put in your toolkit as a network automation engineer is important. So I don't want anybody to think that I'm saying, well, just pick your first thing and just never go anywhere else. But that said, thinking that you are going to be able to become an expert in every single tool that's out there in technology is a bit overly optimistic and can actually result in being overly stressed because there's always more things to learn. And so when people ask, what's the best tool to use? I often say, well, which ones are you already somewhat comfortable with? Are they solving the problems you're trying to solve today? And if they are, then you don't necessarily have to change. Now, if you are looking for new tools or evaluating which ones to look at, then the next thing I suggest is, well, what devices or software versions are you trying to talk to, and what do they support? Because I'd hate to tell somebody, hey, you really should use RESTCONF, and then your entire footprint of infrastructure are devices that don't support RESTCONF. Well, then I gave you some poor information. And so what do your devices support? Let's suppose for a minute that you're lucky and you're in an environment where you're running fairly recent hardware, fairly recent software, and you actually have the ability to pick between CLI interfaces or model-driven programmability interfaces. My recommendation is always, it is better, the sooner you can move to a model-driven or an API-based interface like RESTCONF or NetConf and get away from CLI, likely the better you'll be. Because it starts to take away the requirements from you and your tools to parse CLI output, to be at the whim of CLI and show commands changing the format that's out there. Now, there are plenty of tools that make that easier to work with. I'm a big fan of the PyATS library from Cisco, which works very much kind of in the CLI world. But if I'm just trying to talk to a device, I would much rather do that over a native programmatic interface like RESTCONF than CLI as it goes through on that side. Now, you mentioned Python and Ansible. That to me is another one of those cases, and I think that I've heard from a lot of folks that have had similar experiences to me. Starting with Ansible is great. It's a very easy tool to get going with network automation. But time and time again, I hear experiences from customers and engineers that everybody seems to get to a point with Ansible where their use cases don't fit Ansible as well anymore. Their playbooks start to take 10, 15, 20, 45 minutes to run. They start fighting problems because they upgraded from Ansible 2.8 to 2.9 and then everything broke. And so my recommendation on that type of a thing for most folks is if you're using Ansible today and it's working well for you, that's great. Stick with it. But be aware that most people do eventually start to move away from raw Ansible into something like a Python for automation work. As your own maturity around network automation kind of starts to increase. You don't have to, that doesn't mean give up Ansible today if it's still meeting your needs, but also don't feel like because you made the choice on Ansible, you have to stay with it forever.
But let me ask Judith, add one more thing. As far as the Yang suite goes, as far as a tool for me, and what I learned in this session, right? So there's a lot of things I do when I write a script or I write, what have you. If it's ACI, I do VSOR, right? There's a VSOR page where you can track the model object down and be able to document that object so that you can go in and update it. But as you start moving towards others, a VSOR and Nexus, but as you start moving towards things, that the documentation is nothing is really as neat, right, and properly placed as what I'm looking here on this on the Yang suite, right? So for me, I just move this around. This is probably going to be a tool that I'm going to be using a lot more now that I've seen Hank demo this, right? Because it actually gives me it takes out an element of trial and error, and adds a more resourceful element in plotting out what our model objects are. So I definitely, I'm gonna tell you, there's a lot of gold being dropped here. So that's how I feel about this one. If you want to know how to use it, as soon as you start developing and writing APIs and things of that nature, you're gonna actually see what I'm talking about. You're gonna actually see why I'm so giddy over now looking at Yang Suite. So, sorry, go ahead.
Yeah. Just one follow up. Yeah, I'm just like trying to put them together and try to see how I can navigate this. So I will just drop Python, Ansible now and go just with Python. I know on Postman there's like an option to convert API into a script that you can import in Python. So does Python just come in the path where you want like to transform all those data that you got from Postman and use it, or you can just use it without even learning Python?
That's a good question. So when you're working with RESTCONF and REST APIs, my starting point is always Postman, and I use Postman to learn and understand how the REST APIs work. I often, when I go to actually apply that knowledge to solve a problem, because most network automation problems I work on require more than one API call. If what I was trying to do was just one API call and that was it, then Postman on its own would probably be fine. But when I have to start stringing API calls together, make a request to get information, manipulate that data, send another update request, then I'm eventually going to have to get into Python. That's the language I use. Get into Python and start putting those things together. So I often go from Postman to Python as I start to solve pieces. But my starting point still is usually Postman to explore how these APIs work, understand them. I will build myself up a collection of like little hints and examples of API calls that I can always go back to see how they work. But rarely is Postman where I end with a network automation challenge.
Okay, thank you. That answers me. Yeah, thank you.
I was just going to say that's a really good point, because the thing is when you're programming in Python, you're kind of going back and forth on stuff, and you can sort of do all the calls you're going to do kind of live fire with Postman, and then when you actually get to writing the program, it goes much quicker and it's easier to troubleshoot it there, I think.
Yep, I would agree with that. Now that said, I've got a couple of customers. It seems like ACI was big for this. As I have a handful of customers that their way that they manage and ACI is with Postman collections, as they've built themselves up kind of a library of Postman calls that whenever they need to automate, create something new, like Postman was enough for their use cases. So it doesn't mean that Postman, you have to move beyond it. It kind of just depends on what you're after and where it goes through. I wouldn't bring it up if I hadn't had 3 or 4 different customers tell me, hey, we manage ACI purely with Postman.
I've seen you just true. I've actually seen that, and I look at now that's the first. I actually just saw that a couple of weeks ago, where people are actually repurposing Postman, kind of as if in areas that would use Ansible. You know what I mean? Where it's pre-format is there, and let me run the playbook. Let me give my customer a playbook and move it back away. I've seen Postman, so maybe maybe Postman is actually on a second life here. So I don't know. I've seen that. That's crazy that you brought that up.
Yep, it does work. So again, it just depends on network automation is a value prop spectrum. You get a lot of value with a very little amount of network automation. And then as you add a little bit more network automation, that value goes up. But at every project, every customer, every piece, you get to a point where more effort or more tools or more sophistication in your automation starts to give you less and less value. And so many organizations find that spot where the slope of value starts to level off and say, you know what, I don't have to go any farther, right? We've put in the amount of effort that made sense, gave us a ton of value. Any more effort we put in isn't giving us that much more value. We'll stay here for a while. There's no reason to continue down the slope any farther than you need to.
All right, is there any more questions? Hank, you're awesome. Hank, I want to appreciate you for even freeing up your Saturday for us. You dropped a ton of nuggets. I always learn something when I talk to you, Hank. So, thank you so much.
You're welcome.
Thank
and
you.
Thank you for inviting me and letting me come and hang out for a bit.
All right.
Thank you.
Thank
It was
you.
awesome.
All right, guys.
Do you understand that?